Video 5.1, quadrilateral. So we're specifically talking about trapezoids and isosceles trapezoids. So again, as we talked about previously, all the properties of the quadrilaterals and their relationships to each other. We're going to focus just on trapezoids and isosceles trapezoids. Mainly isosceles trapezoids for this, but the same concepts can apply for trapezoids. But again, there's less properties. There's only one property, at least one pair of parallel sides. So in terms of what we're going to do in their algebraic equations and stuff like that, they usually have a tendency to fall upon isosceles trapezoids a lot more. But again, the same concept can apply to other shapes as well when dealing with them. So first thing is the types of questions that deal with algebraic expressions. So if we look at number 1, right, we have an isosceles trapezoid where they say that AB is parallel to CD. So again, just for your own kind of visual aid here, give yourself a sketch, right, of a trapezoid that looks like an isosceles trapezoid. Again, when you're labeling it, as long as you start, and it doesn't matter which one you start with, just follow along with the information. So AB is parallel to CD. I just have to go in order, so around the figure. But these are the ones that they're telling me are parallel. And if it's an isosceles trapezoid, then that means the non-parallel sides have to be congruent. So that would be these two here. So in this diagram, they're telling me that this is 8x plus 10, AD is, and CB is 3x plus 60. So since we know in an isosceles trapezoid that the non-parallel sides are congruent, I can then take these two sides, AD and CB. I can say that AD is congruent to CB, right? We know that. So that means that I could take the length of AD and set it equal to the length of CB. Now, again, symbolically here, it doesn't look very different, but notice with the congruency symbol, I have the line segment denotion on top. When I'm talking about two things that are just equal in their length or their measure, it's not required for that part, so it's just AD is equal to CB. So algebraically here, let's actually do that. So 8x plus 10, I'm going to set that equal to 3x plus 60, and now I'm just going to simply solve like I would any algebraic equation. I'm going to isolate this and get my x's to one side. By doing so, this should be 3x, not 2x. That eliminates the x's on the right, giving me 5x plus 10 is equal to 60. I can then subtract the 10 over. This is going to get me 5x is equal to 50. And last but not least, I can divide each side by 5 to isolate and get x to be just 1x, which would be 10. So again, when doing these questions, it's all about the setup, being able to set up the equation and then solve it. And the other thing is just make sure you check to see what are you actually asked to solve. I'm asked to find x in this case. So I'm done here. I know what x is. It could ask me to actually find one of the segments. And now that that's the case, then all I got to do is plug it back in. All right, for number 2, again, I now have another isosceles trapezoid that they're describing here. So let's, again, give ourselves a sketch. It's just a general sketch, so whatever helps you out. AB parallel to CD. So again, if I started here, I just know that these are my parallel sides in the way that I drew it. So I'm going to just label it accordingly. Like if I called this A, then this would be B. And then this one would have to be C, and this one would have to be D. Again, because it goes in the order that we have here. Right? So I have to go around the figure either clockwise or counterclockwise, doesn't really matter. It just has to go in the order that is written. All right, so in this case, we're dealing with angle A and angle B. All right, so I look here. So this is A, this is B. These are the base angles in this isosceles trapezoid, and we know that as described up here, we have two pairs of base angles that are congruent. So this is one of those pairs. The other two would be CD. All right, those would also be your other pair. But for this equation, we're not needed. So I'm going to just eliminate those because there's no need for that. We have here. So now I know that since we know that A is congruent to angle B, right? If I'm writing that out, it would also be the measure of angle A is equal to the measure of angle B. So symbolically, that's the two different ways of denoting the information. Again, the standard version with what we've been doing so far is congruency, is when you don't actually have a value or a length or a measure. If I'm dealing with an angle measure and I actually know the actual amount, I put that little m in the front to represent that. So again, that's just how you would denote it symbolically, and then we can actually go and solve this. So again, 10x plus 30, we're going to set that equal to 14x plus 10. And once again, we're solving this equation, so I'm going to isolate my x. So I like to keep my x positive, so I'm going to remove the 10x. You could simply move the 14x over if you would prefer. If you want to keep everything, the x on the left side, if that's something that bothers you, by all means do it. But again, that's just a process of solving, whichever one's more convenient for you. That's all you're really looking for. So as we go through here, again, the solving the equation portion, if you have any difficulty with that process, you want to make sure you go back, look over old notes, old videos, to really work on the practice of solving those things and being able to set it, find the particular steps that work for solving the equation. All right, so we did this. We found an x. And again, I circled this one because I'm not done, right? The question asks me to find angle A, right? This is just x. X is 5. I got to go and I got to plug this back in to whatever A actually is. So angle A equals 10x plus 30. So I'm going to say, well, angle A, right, or the measure, whichever we want to write it, is equal to 10 times, and I'm going to plug in my 5 that we just found here, 4x. So that gives me 50 plus 30, and that's 80. And in this case, it's an angle, so that's a degree. So angle A, or the measure of angle A, is equal to 80 degrees. So there's the two examples of kind of how we can utilize the properties of an isosceles trapezoid and their actual values and or lengths and sides and segments and stuff like that algebraically. The other thing that can be done is a proof. And this would be just like a standard proof that we had done in the previous unit, and that is statement, reason. And we're going to do this just like we would any of the triangle congruency proofs. We're going to systematically go through and try and prove whatever we're asked to prove. So first thing we're going to label is our first given here, which is ABCD is an isosceles trapezoid. And that's an important one because that gives us a lot of information. It actually gives us all three of these things immediately. So once they state that I have an isosceles trapezoid, that means all three of these conditions are open to us to use. We may not use them all, and most of the time you don't, but they're open to us. All right, so let's see. Before I'm going to use any of them, I do have a little bit more because I know that the goal here is to prove that triangle DEA, which is this triangle here, right, and triangle CFB, which is this one over here, that's my goal here, right? So if I take a second and look, the second given here is that they're telling me that these two sides of my isosceles trapezoid are my parallel sides. So I'm going to write that down and use that because if I know that these are my parallel sides, then based on the information given here, I can say that the non-parallel sides are congruent. So therefore, my non-parallel sides would be AD and CB. So therefore, I can now make the conclusion that AD is congruent to CB. And the reason is going to say, because in an isosceles trapezoid, the non-parallel sides are congruent. Again, I like to use this line here. I dictate this as my because. So when I'm reading this, I'm saying 3 statement 3 is AD is congruent to CB, and again, think of this as because, right? And then this is my reason, because in an isosceles trapezoid, the non-parallel sides are congruent. Kind of helps you to flow when you're kind of writing this out. All right, next. My next statement here is DE is perpendicular AB. I also have another one, so I'm going to write them together because we're all just dealing with perpendicular sides here. So this is all given. Again, you can write it as two separate statements if you wanted to, and separate reasons. But it's all given and it's all the same, so might as well. All right, so what does it do for me, right? Well, if DE is perpendicular to AB and CF is perpendicular to AB, that means I've got right angles. And again, I'm specifically going to highlight these two because I want the ones inside. So I can't just say angle E and angle F, too vague. So I'm going to be more specific. I'm going to just number them. So I'm going to say angle 1 and angle 2 are right angles. And my reason is because perpendicular lines form right angles. And then again, whenever I say that, I'm always going to follow it up with that. Not only are those right angles, but that they're also congruent, because all right angles are congruent. So now I need another piece of information. So I've used all my givens, right? This first two, these two here. So I'm like, oh no, what am I going to do? I don't have anything else to work with. Well, I go back and I look at the information that I've been provided, and the fact that I have an isosceles trapezoid, again, it gives me more information. It gives me all three of these things. So looking at these, I go, wait, I also have this second one where it says pairs of base angles are congruent. So I look to see, is any of that information going to help me? And I do. I have this angle A and this angle B would be base angles of my isosceles trapezoid. So I can say now that with 7, I can say that angle A is congruent to angle B. And again, those are single angles, so I can actually denote it with just A and B. If you want to call it 3 and 4, you could. Just may gotta label it. Sorry, this is 7. And then again, we're going to say in an isosceles trapezoid, base angles are congruent. And that now gives us our 3 pieces of criteria here, which allows us to actually make the statement that we're looking to prove, and that is triangle DEA is congruent to triangle CFB. And that is going to be, again, I have 2 angles and 1 side. The side is only touching one of the angles here, right? The green angle, right? So therefore, it's angle, side. So angle, side is congruent to angle, side. Again, if it was going to be angle, side, angle, the side would have to be touching both angles in order to use that one. All right, so this is the process. This is what we're going to utilize. This is kind of what we're going to see throughout this unit, at least the beginning portion of this unit, and that is using the properties to solve algebraic equations or situations. And then we could also do actual proofs and actually be able to prove whatever information or criteria they're asking us to prove when we're given the specific type of quadrilateral that we're talking about. And again, we're going to break this unit up. So the second part of the unit is going to be when we are actually asked to prove that we have one of these quadrilaterals in that sense. But this is what we're going to do here. So take an opportunity, watch the video, look over different parts, take your notes, and if you have any questions, we'll talk about it later on.